And today I want to talk about the law of signs, solving triangles using the law of signs, specifically for the ambiguous case. You'll remember that when we have an angle and a side in this sequence, this is the same scenario that disallowed us from proving triangles are congruence because of this. And the problem is, it's possible that this side can swing over here, and I'll show that again in a minute. But it begins as normal. I'm going to say that I want to use the law of signs. And I know that I can use the law of signs because when I plug these values into my little handy chart, I see that I've got a 32 here, and then the side opposite A, which is my little a, has a 7. The side opposite C has a 10, and I don't know any other information. But by having this pair, one of these ratios is going to be satisfied. So I'm going to begin by doing the sine of A is to A as the sine of C is to C, because I've got a value for C. I'll plug these in. Sine of 32 is to 7 as the sine of C is to 10. And as always in these problems, I'm going to cross multiply to solve my proportion. I'm going to get 7 times the sine of C is equal to 10 times the sine of 32. I'm trying to solve for C. Right now it's kind of muddled up in here, but I see that I'm being multiplied by 7, so I can get rid of that to start with. So now I've got the sine of C is equal to 10 times the sine of 32 over 7. Still want to solve for C. What's being done to C right now? Well, C is being signed. So I'm going to need to inverse sine both sides of the equation. By doing that, this side just becomes the C, and on this side I get the inverse sine of this expression, 10 times sine of 32 over 7. I'll plug that into my calculator. Second sine of 10 times sine of 32 divided by 7. And I get a value of approximately 49.203, let's say. And I'm going to write that in up here, 49.203. Now, how do I get into B here? Well, I've got 2 of the angles, so I should be able to find the third. I know that A plus B plus C is equal to 180. So 32 plus B plus 49.203 equals 180. So 81.203 plus B is equal to 180. So B is equal to, let's make sure I don't say a mistake, 98.797. Okay, so I can add that in up here, 98.797, and I can solve for the third side, B, by again using law of signs. So I would say the sine of A, so I'd say sine of 32 is to 7 as sine of B, 98.797 is to B. Excuse me, cross multiply and solve. This time I'm solving for B and it's being multiplied by sine of 32, so I divide by sine of 32. That's my precise answer. I want a decimal approximation, so I'm going to say 7 times the sine of 32 times the sine of 98.797 divided by the sine of 32 gives me 13.054 approximately. And it looks like we're done. We've solved the triangle because we have all the parts. However, this particular triangle, because it's the ASS, is the ambiguous case. So I need to draw this again and set up a little table to track my values. We already knew about 32. That was given to us originally, and the 7 was given to us, and the 10 was given to us. We found this C. That was the first thing we discovered, because it was the rest of this proportion. The reason this is an ambiguous case is, well, this angle is locked, and this side length is locked, and this side length is locked. This angle up here is not locked. It can swing. So this side could theoretically swing around all the way over to here and position itself there, still be 7 in value, but it changes the triangle dramatically. And whereas here we had found that this was 49.203, this angle is going to be different. How can we find it? Well, if this is 7 and this is 7, that makes this an isosceles triangle. If it's an isosceles triangle, then we know that this angle will be 49.203 as well. Both of these base angles would be the same, which means when I had these angles of A, B, and C, I'm going to call that C1 because it's the first C we found, and this is going to be B1 and B1. But now in the second scenario, what I'm looking for is a second C value and the second corresponding B's and B's. So in this triangle now, what do we know about this angle? We're going to call it effectively C2. And it is the supplement of what we had previously as C1. So C2 is equal to 180 minus C1, which would be 180 minus 49.203, which is equal to 100. Make sure I don't make mistakes, right? So we now know that the second C value, the second angle, is 130.797. And it's at this point that we can decide whether or not this is ambiguous because we have two triangles, or whether it shouldn't have been ambiguous in the first place because there's only one. And the reason is we decide whether there's a possible B2. Just like we did here on the first time. We found our version for angle C, and then we went further and said, I know that A, B, and C make 180, so I can find the measure of angle B. And these were both our C1 and our B1. We do the same process. We just found C2, so we can find B2 by saying that A plus B2 plus C2 has to equal 180. So 32 plus B2 plus 130.797 equals 180. So B2 plus 162.797 equals 180. So B2 is equal to, subtracting there, I get 18, so 17.203. 17.203. So that's the value of B2. Having now found B2, I can find what we needed to find, which is the last piece of the triangle. I can say that the sine of angle A over A is equal to the sine of B2 over little b2. In our case, that means the sine of 32 is to 7, as the sine of 17.203 is to our unknown B2. Cross multiply to solve. B2 times sine of 32 equals 7 times sine of 17.203. This has been multiplied, so I divide. B2 is equal to 7 times sine of 17.203 divided by sine of 32. 7 times sine of 17.203 divided by sine of 32 gives me that a B2 value is approximately 3.907. Does that make sense? Let's see, our smallest angle is facing our smallest side, our mediumest angle is facing our mediumest side, and our largest angle is facing our largest side. That's correct. So that's the process for solving an ambiguous case of a triangle using the law of sines. Thank you very much.